Hello everyone. Can you all hear me, students? Can you all hear me, students? Hello. Can you all hear me?
Good morning. Good morning, sir.
Uh, can you all hear me? Can you all hear me? Yeah. Hello, hello. Am I audible to all of you?
Yes, sir.
Okay, fine. So, in the last class we discussed regarding the what do you call it? Question paper. So today what we will discuss is we'll continue the chapter work power energy. Okay. So can you see my screen?
No, sir.
Okay, wait just a minute. Can you see it now?
Yes, sir.
So what we are going to decide discuss is motion in an inclined plane. Okay. So in the previous articles we have discussed the motion of bodies on level surface. But sometimes the motion of a body takes place up or down on an inclined plane. Okay. So this is shown by this figure, right? So if you see this figure, you can see that if you see this figure, you can see that here what happens is that this this is an inclined plane, right? Since this is an inclined plane, so the body is in a motion here or it is moving here. Okay, the body is moving either upwards or either downwards, right? So if the body is moving either upwards or downwards, then we can say that the body is in an inclined plane motion. Now here if you see the angle through which this inclination is taking place, this is alpha. Okay, the angle through which this inclination takes place, this is alpha, and if you see the body is if you see the body is either moving or moving downwards. Now here we are assuming that m is the mass of the body, and alpha is the what?
Angle of inclination.
Good, very good. The angle of inclination of the plane. Okay. So alpha is the angle of inclination of the plane. Now, if you see the normal reaction on an inclined plane due to mass of the body. The body is having what? Mass m, right? So if the body is having some mass m, then the body will give some normal reaction. Now always remember one thing. This normal reaction, okay, this normal reaction is what? Is always perpendicular to the body. Look at this. It is not perpendicular to the horizontal, but it is perpendicular to the body. If the body is inclined, then the normal reaction will be also inclined. That means what? This is 90 degree. Okay, this angle. I'll rather say this angle. Okay. So this is how we show or we express normal reaction. Okay. So what happens is that normal reaction R equal to what? Mg cos alpha. R equal to mg cos alpha. So R if R is equal to mg cos alpha, this component is responsible for what? Force of experience, force of friction, which is experienced by the body. Okay. This component basically is responsible for the frictional force. So this component is basically responsible for the frictional force. Now this one is gone. Now what happens? We also know that component of the force along the inclined plane due to mass of the body. It is mg sin alpha. Now look how to derive this. I showed you in the previous classes also. Okay, today also I am showing. Look, this m, I'll just zoom it out, then I'll show you. Now this m, can you see the zoom thing? Can you see the thing in zoom, students?
Yes, sir. Yes.
Yes, sir.
So here, look, we will have two components. The components are what? One is sin theta component and the other is what? Cos theta component. Huh? Now here, if you drop a perpendicular, sorry, wait, huh? So here, here it is inclined now. So if you drop a perpendicular like this from here, that means this is straight. Then this M and this perpendicular, they are making an angle. Yes or no? This angle between them. This is the angle, if you can see. Can you see? Here will be one angle, no? Yes or no? Students?
Yes, sir. I can see this angle.
समझ में आ रहा है तुम लोग को?
Yes, sir.
हाँ,
Yes.
sir. हाँ.
Okay. So there will be an angle. So can you tell me the value of that angle? Can you guys tell me the?
Alpha.
What is the value of that angle?
So it is equal to alpha, I think.
Very good. Not I think. You should give it in confident manner. Then it will be good, na? So this angle is what? Alpha. Now look. Now here what happens? This is one part and this is another part. So this is M. Now if M is there, now look. Force is what? F equal to what? F equal to mg.
Mass into the acceleration.
Mass into what?
Acceleration.
Mass into acceleration. For acceleration, we can consider it as z, which is acceleration
Gravity.
due to gravity. Can you, yes or no?
Yes, sir.
So if we consider this z, then we'll get what? It will be mg here. This portion will be mg, right? This portion will be mg. Now this angle is what? This angle is alpha. This. So what will be this one? What will be this one then? What will be this part?
MG equals
Mg cos alpha. Very good. So this one will be what? Mg cos alpha. Like this. Mg cos alpha. Right. If this one is Mg cos alpha, then what happens is that if this one is Mg cos alpha, then you can say one thing now. This part, this R is what? If you extend R, it will be like this. It will be this perpendicular only. Wait, I'm showing. If you extend this R, this will be like this only. Yes or no? If you extend R, this will be like this only. Then this, if this is mg cos alpha, then we can say that what? R equal to
MG cos
what?
alpha.
R equal to, we can write it as, very good, mg cos
Cos alpha.
alpha. है कि नहीं? तो if R equal to
Right, sir.
what?
Sir.
If you understand, it's okay. Okay? The other people should also understand, na? R equal to mg cos alpha. Now here on this side, we are having what? Which component? mg sine alpha. Yes or no? In this direction, we will be having one other component which is mg sine alpha. Right? So if you are having this, we are having this. So the component of force along the inclined plane of the body is mg sine alpha. This component is responsible for sliding or moving the body downwards and is known as gravitational pull. One is cos, the other one is sine. The normal direction R is equal to mg cos alpha. This R equal to mg cos alpha thing, this component is responsible for the frictional force that is experienced by the body. Okay? And due to the inclined plane, this will be what? Mg sine alpha. Now the component responsible for sliding or moving the body downwards. This is known as what? Gravitational pull. Okay? This thing is known as what? Gravitational pull. So now we can find out the work done in moving the body or power required for motion by subtracting the force of friction due to normal direction from the component along the inclined surface. That means mg sine alpha. So how can we find out the work done in moving the body or the power required by the motion? This will be what? Subtracting the force of friction due to normal direction from the component along the inclined surface, that means mg sine alpha. So now we'll do one numerical, then you will understand the concepts. So now, suppose if you are required to find out the work done for an inclined plane, that means what? The force you have to find out first, and then distance. Now, if you see the diagram, which component will be the force? Can you say me?
But we can't see the diagram, sir.
I showed you the diagram beforehand. No? Do you want to see it again? Wait, then I'll show you.
Better.
Can you see the diagram now? Can you see the diagram now?
So we can see.
So in this diagram, what you can see, the mg sin alpha component. So this is the what? This is the component of force along the inclined plane, right? So if this is the component of force along the inclined plane, then this component is what? This component is basically responsible for moving the body downwards, or the motion of the body. This component is responsible for the motion of the body, right? So if this component is responsible for the motion of the body, then we can say that the sin alpha component is the what? Force that is being applied, right? So in an inclined plane, if you are required to find out the force, then this force is what? This sin alpha thing. Is it clear? Is it clear now?
But in the sir upward motion, sir.
दोनों में होगा. अगर ऊपर जाएगा तो the upward will be there. If it comes downward, then it will be downward. If the body is moving
But
upward, but what?
but when it's going upward, but there will be no motion due to the gravity, I think. So
Gravity के लिए
can we
नहीं
put
होगा.
mg in the sign?
क्यों नहीं होगा gravity के लिए? When you are moving in a hill, suppose, don't you think that gravity is acting on your body? If you are walking on a hill, huh? If you are walking on a hill, what happens? If gravity is not acting, if you are jumping, then you will be upper. You will be staying in up only. Yes or no?
Yes, but due to that gravity, we are not going upward
This
in
is
upward
not due
motions.
to gravity. This is because gravity is always acting. Got
That's
it?
it.
Gravity is always acting, right? Huh? So if gravity is
Okay.
always acting, then what will happen? How is it possible? समझ में आ गया? ग्रेविटी तो तुम पर सब हमेशा एक्ट करके रहेगा ना.
That's fine. But gravity act to head, but in upward direction, it will be in opposite, I think. Opposite.
Gravity will be opposite. How can gravity be opposite? तुम्हारे सर
वो
से
तो
कब
हम लोग को
खींचता है?
खींचेगा ना. वो तो हम लोग को जब पहाड़ में उतरा होगा, वो तो हम लोग को खींच के डाउन करेगा ना. वो तो ऊपर
खींच
तो
के
हम लोग
डाउन
को नहीं
कैसे करता है?
उठाएगा.
तुमको खींच के डाउन कैसे करता है? तुमको पीछे से खींचता है कि पैर के नीचे से खींचता है? बोलो तो. You are saying that gravity is pulling you backwards. So is it pulling you from
Yes.
backwards or is it pulling you from below the feet?
Anyway, sir, but it
How? No, no, no. This one is the concept. Now what anyway? You just tell me that.
yes, sir.
बोलो,
From
बोलो.
it's from the legs. Okay, okay, it's fine. But it
क्या फाइन? तो लेग से अगर होगा तो क्या होगा? मैं क्या समझा रहा था तुमको? If it is from legs, this is what? M ना? So here only the mg component will be there. Mg will be there downwards ना? Yes or no? If this is downwards, then we are resolving it to sine and cos. So this is the what? Sine. ये साइन होगा ना. समझा?
yes, sir.
ये साइन होगा ना. तो अगर ये
Yes,
साइन
sir.
होगा तो क्या होगा यहाँ पे? बोलो. ये mg sin alpha होगा कि नहीं? This will be mg sin alpha or not?
ये cos हो गया.
So this will, if this is sin alpha, then what happens? So this is the component because this is inclined at an angle. We are not taking mg directly. Just remember this thing. We are not taking mg directly, right? We are not taking. Oh, wait. हम लोग थोड़ी ना mg डायरेक्टली ले रहे हैं. हम लोग क्या ले रहे हैं? हम लोग इसका साइन थीटा पार्ट ले रहे हैं. साइन थीटा इस साइड में होगा ना? नहीं समझा?
Yes, sir. Yes, sir.
Now is it clear?
Okay, but in here mentioned mg sine alpha,
Hmm.
this component responsible for the sliding or moving of the downward body. What about upward body, sir?
If it is given some forces in the upward or if it is inclined in the other direction, then it will be moving in the upward direction.
That is what I'm talking about.
This is the special case, okay? This is a different case. Generally, the body will move downward only. Yes or no?
That's right.
अभी बॉडी तो जनरली डाउनवर्ड ही मूव करेगा. अगर
Yeah.
कभी अगर कभी I'm telling you, when work is said to be done, what happens? Some force is applied from this side, no? Then or someone is pulling from this side if it is moving upwards. Then only it will move upwards, right?
Yes, sir.
That's what I'm saying. समझा अभी मैं क्या बोल रहा हूँ तुमको?
Yes, sir.
Clear है? So what we will do is, so the force can be found out by mg sin alpha. That means sin alpha component is the force component. And
Okay.
and this cos thing will be what? The r. R means the normal reaction or the friction, right? So if these two things are being found out, then you can get the overall answer. So let's do the numerical. If you have any doubt, you can ask me in the numerical. Try solving the numerical and tell me the answers. I'll share a numerical now. Just give me a minute. Can you see? Can you see it?
Yes, sir.
Yeah. Please mute your mic. Someone noise is coming. Try solving it. Don't give the attendance. Why you give the attendance every day in the morning only? I did not ask anyone to give the attendance. No? This will not be considered. Please try to maintain the decorum.
নমস্কার।
Sir,
বলো
my answer, is it the answer 5072.8 joule?
5072.8 what?
8 joule.
I would say you write in the chat box. I'll say. You just write in the chat box. I will just say because let your friends complete. Okay. Just write in the chat box. Many people are writing. You see. Okay, I got many answers. Let's see the answers. I want at least more answers. More people should do it because every time I give any numerical to do, I get hardly 6, 7 answers. 2, 3, 4, 5, 6, 7. Yeah, 6, 7 answers. Okay, so I should get more than 20, at least 50% of the class should do the numerical. And if they don't understand, also they should ask me actually, rather than just connecting and sitting. Okay, yeah, answers coming now. Wait. Okay. Okay. So let us discuss the numerical now. Okay. Can you see the answer? Can you see the answer?
Yes, sir.
So many of you got in joules. So it's correct only. If you get in joules, if you get in kilojoules, it doesn't matters. It's correct only. Okay. So if you get in joules, it will be 5072 point something joules. Okay. And kilojoule, this is the answer. Okay. This is how it is being sorted out. Right. So here, if you can see, the mass of the block is what? The mass of the block is 200 kgs. Right. So the mass of the block is 200 kgs. And for 10 meter on a, the work is done for 10 meter. Now someone asked me now how it is being done. Look, this block is been pulling up. Pulling up means what? Some force is applied, right? That force only we find out by this sin theta component. Now did you get it? How is it moving by the sin theta component? Hello, someone asked me now how it is pulled up. The question, if it is given,
Yes, sir. Yes, sir.
so it is being pulled up, right? In the question only
Yes.
it is given, it is being pulled up. That is how we get the sin theta component only in that direction. Na? If it comes down, if it is pulled up, whatever may be. So,
So here, sir, sin mg sin theta work as a resisting force. That is why I was confusing, sir. Okay, fine.
ठीक है अभी अभी ठीक है ना हेलो
Yes,
हेलो
sir.
अभी ठीक है ना
Yes, sir.
ओके चलो तो क्या है अभी इफ यू सी हियर द मास इज व्हाट 200 kgs right the distance is meter in given in meter mass is given you know g you know the angle it is simple mg sin alpha. That's it. So it is done in that manner only, mg sin alpha. So you should always keep your calculators in hand because these numericals requires calculators, right? So you should keep your calculators in hand for solving the numericals. So mg sin alpha. This is how it is being done. And this is what this mg sin alpha thing is the force. No? So if this thing is the force, you just found out the force like mg 2000, 200 into 9.8 into sin alpha. Alpha is what? It is given as 15 degree. Now look, suppose if the angle is given 15 degree with the vertical, so what will be the alpha then? Can you tell me? Now in place of horizontal, if it is given 15 degree with the vertical, what will be the answer?
One
Alpha का value क्या होगा
okay.
रे? मतलब just tell me the value of alpha. No need to calculate it. Just tell me the
90 plus 15.
90 plus 15 कैसे होगा रे?
वर्टिकल होने से आपका
बोलो तो.
M mg cos
minus
cos alpha.
No, no need to change the sign. Just tell me the angle of alpha. How will the alpha change?
15 होने से आपका
बोलो तो. Value बोलो मुझे. Just tell me the values. Others also please try.
90 minus 15.
तुम value बोलो ना.
75.
So this is, yeah, people are saying correct answers only. I'm asking it like this. If
5. Okay, fine.
this is the angle, if it is given inclined at an angle of 15 degree with the vertical, then alpha will be how much? Someone said the correct answer only just
5.
now. Huh? Someone
90
said
minus
90 minus what?
90 minus 15, which is equal to 75.
Good, very good. So it will be 90 minus 15. In the question, that is why you just check it out whether it is given 15 degree the horizontal or vertical or something like that. Now understood? Did you understand now?
Yes, sir. Here some, but there is some unit. Mass is in kg and the distance is in meter. So we need to convert it. But here they do not convert it. Just calculation. I think.
Why to convert it? Don't you know
क्योंकि
Newton?
मास जो kg में है
Newton
आपका
meter per
200
second
kg में.
means what? Newton meter. Newton means what? Force, right?
Yes.
Force equal to what? mg. तो मास केजी में ही होगा ना, तो कहाँ तक कन्वर्ट करेगा तुम? 1 न्यूटन इक्वल टू व्हाट?
Okay.
केजी पर मीटर, केजी मीटर स्क्वायर ना, तो कहाँ तक कन्वर्ट
Okay.
करेगा तुम? ये तो केजी पे होगा, ठीक है? समझा?
Okay. Okay. Fine.
Do you understand? Okay.
Second.
So please ask me if you have any doubts.
Sir, can you hear me?
I can hear you say.
Sir, you just said that we have to change that angle 15 degree into that angle. I just put the value of the 15 degree.
No, you put the value of the 15 degree, but if you have said in cos now,
Yes,
just
sir.
now. If you do it in cos, then it doesn't make a big deal. It's the same only. But for simplicity, I'm only saying that better you convert it to horizontal, because in exam it might get messed up and confused. Are you getting me? What I'm saying? It's up to you.
But
It's up to you. You just
I
need.
can put the same degree, na?
You can put the same degree, but you have to change the sign then. Na? If it is in vertical, if it is in horizontal, then it's okay. It's in sign only.
Hmm.
Understood?
In case of vertical, I have to change that angle, na?
You have to change the angle. Better you change the angle. Keep the formula same, mg sign. Make the alpha 90 degree minus that one, the angle that is inclined in the vertical, if it is given in the vertical.
Or
Got
in
it?
case of vertical, we have to change that.
Yeah, in case of horizontal, you no need to change it.
Okay.
Understood? Clear, everyone?